Hey everyone, welcome back for another deep dive. You ready to talk about something truly revolutionary?
Always.
Today we're diving into the world of perovskite solar cells, the potential next big thing in solar energy.
Absolutely.
Just imagine solar panels so lightweight and flexible that you could put them on windows.
Oh, wow.
Curve them around buildings, anything you can think of.
Yeah.
And the best part is they're already as efficient as those bulky silicon panels that we see everywhere.
It's perfect timing, too.
Oh.
Think about it. A global electricity demand is just exploding.
With everything going electric, right.
Exactly. AI, electric vehicles.
Right.
Everything's becoming more energy hungry.
Yeah.
So we need clean power, and we need a lot of it.
We've kind of learned the hard way with those first-gen silicon panels, though, haven't we?
We have.
Recycling them is a total nightmare.
Oh, yeah.
Leading to mountains of e-waste.
It's a problem.
We can't afford to repeat that mistake.
Exactly, and that's what makes this research out of Linköping University so exciting.
Yeah.
They just published a paper in Nature.
Uh-huh.
They've cracked the code on fully recycling perovskite solar cells.
Really?
And get this.
Yeah.
They're using mostly water.
Water.
Did you have a...
Cycle solar panels?
Yes. No harsh chemicals.
Wow.
No mountains of toxic waste.
Okay, using water to take apart a solar panel? That sounds almost too good to be true.
I know, right?
So what's the science behind that? How does that even work?
It's surprisingly elegant.
Okay.
Perovskite cells are made of layers.
Layers.
Kind of like a high-tech sandwich.
Uh-huh.
This new method uses water to gently separate those layers without damaging the materials.
Wow.
We're talking about the glass, the electrodes, the perovskite layers themselves, even the charge transport layer.
Hold on, the charge transport layer?
Yes.
What is that?
For those of us who aren't material scientists.
Exactly.
Thinking it as the traffic controller of the solar cell.
Gotcha.
It helps the electrons that are generated by sunlight flow efficiently to create electricity.
Oh, I see.
Recovering that layer intact is crucial for maintaining performance in the recycled cell.
So they're not just melting everything down into a useless blob.
Not at all.
They're actually separating out all valuable components.
Exactly.
Incredible. But what happens to those recovered materials?
That's the best part.
Yeah.
They can be used to manufacture brand new perovskite cells.
Okay.
And here's the kicker.
What's that?
The recycled cells perform just as well as the originals.
No way. That's a big deal, right?
It is.
I mean, usually when you recycle something, there's some loss of quality.
Exactly.
How are they managing to maintain?
That's what makes this research so groundbreaking.
Okay.
See, the traditional silicon solar cells recycling often damages the materials, leading to a drop in performance.
Makes sense.
This new process for perovskites is so gentle that it preserves the integrity of the materials.
Wow.
Allowing them to function at their peak, even after being recycled.
So no performance drop-off?
Nope.
That's huge for making these cells commercially viable.
Huge.
But there's one thing that always comes up with perovskites.
What's that?
It's the lead content.
Right.
Doesn't that raise some red flags?
It's a valid concern.
Yeah.
Perovskites do contain lead.
Right.
Which is vital for their high efficiency.
Yeah.
But obviously poses environmental risks.
Yeah.
The beauty of this recycling method is that it safely captures and recovers that lead, preventing it from leaching into the environment.
So it's a double win then.
It is.
Not only are they recycling the panels themselves, but they're also preventing a potential lead contamination problem.
Exactly.
I have to admit, the idea of putting solar panels on windows is incredibly cool.
It is pretty cool.
What other crazy applications are we talking about here?
Imagine flexible solar cells.
Okay.
Woven into clothing.
Really?
Powering wearable electronics.
Oh, wow.
Or camping gear that generates its own energy.
That's interesting.
And because these cells can be transparent, picture skyscrapers with windows that double as power generators.
Oh, wow.
Yeah.
Okay, so we're talking about turning entire cities into energy-generating hubs.
Think about it.
This is incredible.
Yeah.
Let's be realistic, though, for a second.
Sure.
What are the hurdles? What challenges do we need to overcome before this
good question.
Sci-fi vision becomes a reality?
You're right. It's not all sunshine and roses.
Right.
One major challenge is the lifespan of these cells.
Oh, okay.
Currently, they don't last as long as traditional silicon panels.
How long do silicon panels last?
Those can operate for 25 years or more.
Wow. Okay. So durability is a big one.
It is.
But I'm guessing researchers are working on that?
Yeah, absolutely.
What's the latest on that front?
They're developing more stable perovskite materials and better protection from the elements.
Oh, that makes sense.
Recent studies show they're getting closer to matching silicon's lifespan.
Okay.
But it's not just about the science itself.
Right.
It's about building an entirely new industry around these cells.
What do you mean?
We're talking about manufacturing, supply chains, training, a massive undertaking.
It sounds like we're on the verge of a major energy revolution.
It really does.
But a lot needs to happen.
A lot needs to happen.
To make it a reality.
Yes.
We'll delve into those implications.
Okay.
Right after a quick word from our sponsors.
Sounds good.
All right, we're back.
Yes.
And ready to unpack implications of this Perovskite breakthrough.
Right.
We were just talking about the hurdles, lifespan, scaling up production. What happens?
That's when things get really revolutionary.
Oh.
We're potentially talking about a complete reshaping of our energy landscape.
So not just solar farms in the desert.
No.
Solar integrated into our everyday lives.
Exactly. So we've talked about buildings generating their own power.
Yeah.
But take it further, electric vehicles.
Sure.
Directly from their own solar-coated surfaces.
Wow.
Entire communities becoming energy independent.
Oh, wow.
Resilient to grid outages.
That would be incredible.
Yeah.
Okay, now we're talking about some serious future is now stuff.
Yeah.
But let's not forget about the economic side.
Right.
If perovskite production is cheaper than silicon, and now we can recycle it efficiently, what does that do?
Well, to the cost of solar energy overall, it has the potential to make solar incredibly affordable.
Even more so.
Yes, even more so.
But it already is.
That it's becoming already.
Okay.
And not just for wealthy nations, but for developing countries.
Oh, yeah.
Where access to reliable, clean energy is a game changer
for sure.
For economic growth and quality of life.
So this isn't just about saving the planet.
No, it's not.
It's also about leveling the playing field.
Right.
Giving everyone a shot at a brighter future.
Exactly.
So if perovskites are so amazing, why aren't they everywhere already?
Good question.
What's holding them back?
Well,
besides those lifespan and scaling challenges we talked about?
There are a few other factors at play.
Like what?
One is simply awareness.
Okay.
Perovskites are still relatively new on the scene compared to silicon, which has had decades of research and development behind it.
Okay. It's a bit of a marketing challenge, too.
You could say that.
Getting the word out about incredible technology.
And then there's the investment side of things.
Oh, right.
Silicon has a massive existing infrastructure built around it.
Yeah.
Factories, supply chains, trained workforces.
Right.
Shifting to perovskites will require a significant investment in new infrastructure and expertise.
But wouldn't that investment be worth it in the long run?
I think so.
Considering the potential benefits, both environmental and economic.
Absolutely.
So it's kind of a chicken and egg situation.
It is.
We need the research to advance the technology, but we also need investment and policy support to scale up production and make it commercially viable.
Precisely. But the momentum is building.
Okay.
This breakthrough in recycling is a major step forward.
Okay.
And as more people become aware of the potential of perovskites, I'm confident that the investment policy support will follow.
This has been an incredibly insightful dive into the world of perovskite solar cells.
It has.
The science, the potential, the challenges.
It's fascinating, isn't it?
But before we wrap up, I want to leave our listeners with something to ponder. We've talked about the potential of perovskite solar cells to revolutionize energy, but what does that actually look like? If we fast forward a bit, and these cells are as widespread as silicon panels are today, how does our world change?
It's a fascinating thought experiment.
Yeah.
For one thing, I think we'd see a dramatic shift in the aesthetics of our cities.
What do you mean?
Imagine buildings draped in sleek, transparent solar films.
Oh, wow.
Capturing energy without sacrificing natural light.
Yeah.
Rooftops could transform into lush gardens.
Oh, wow.
Providing food and energy.
Oh, that's cool. That's a far cry.
It is.
From the clunky solar panels we're used to seeing.
Yeah.
Sound almost utopian.
It does.
But wouldn't such a dramatic shift also disrupt existing industries and power structures?
Undoubtedly.
Yeah.
The shift to a perovskite-powered world would create winners and losers.
Too.
Fossil fuel companies, for instance, would face major challenges.
Yeah, for sure.
As demand for their products plummets.
Right.
We could see a resurgence in domestic manufacturing as countries seek to control their own energy production.
So it's not just about technology.
No,
it's
about geopolitics, economics, even social change.
It makes you wonder,
right?
What happens to those who are left behind?
That's a critical question.
Yeah.
And one that we need to address proactively.
How do we do that?
As we move toward a perovskite-powered future,
right.
we need to ensure that the benefits are shared equitably and that those who are displaced by the transition have opportunities for retraining or reskilling.
That makes sense.
The goal should be to create a future that's not just sustainable, but also just inclusive.
It's a reminder that technological advancements, no matter how groundbreaking, need to be accompanied by thoughtful policies and social safety nets.
Exactly.
Otherwise, we risk exacerbating existing inequalities.
Absolutely.
We need to be mindful of the unintended consequences of even the most well-intentioned innovations.
It's our responsibility to ensure that the transition to a perovskite-powered world is a just and equitable one.
Well, folks, there you have it.
We covered a lot.
A deep dive into the world of perovskite solar cells.
Fascinating stuff.
And their potential to reshape our energy landscape.
It is.
From the science behind these remarkable cells to the broader societal and economic implications.
Right.
It's clear that we're on the cusp of something truly transformative.
This research from Linköping University is a pivotal moment in the journey toward a sustainable future.
It really is.
It demonstrates that a circular economy for solar energy is within reach.
Yeah.
And that we have the tools to create a world where clean energy is abundant and accessible to all.
As we move forward, let's remember that the future is not something that simply happens to us.
It's something we create through our choices, our investments,
and our collective commitment to a better tomorrow.
I like that.
So let's keep exploring.
Let's keep exploring.
Keep questioning.
Keep questioning.
And keep pushing the boundaries of what's possible.
Absolutely.
The future of energy is in our hands.
It is.
And with technologies like perovskite solar cells, it's looking brighter than ever.
I'm hopeful.
Thanks for joining us on this deep dive.
It's my pleasure.
Until next time, stay curious and stay engaged.
Stay curious.
The world is full of fascinating discoveries waiting to be made.